if you're going through billions of rows, we're talking about large data sets, we're talking about many concurrent users accessing rows at the same time. It is important that all the processing through the stream is very effective. We found that joining billions of rows can be a real challenge. It can sometimes already be a challenge joining millions of rows. So Swarm64 has added a specific join type or specific join types that can be chosen to join together larger data sets very effectively and with a high degree of parallelism. In fact, the whole more parallelism during query execution is one of the important features in Swarm64. And finally, parallelism is often blocked by things like data distribution and data movement. You need to shuffle your data, move it between different execution nodes effectively in order to keep parallelism active. And you need to optimize the movement of data in between processing steps. Let's look at this in a little more detail. Here we've got a very regular query. So when we mean complex queries, this is what we're talking about. You're scanning and filtering a couple of tables, you're joining them. Maybe you have a unique constraint or something similar. Maybe you want to see an aggregate, then you're joining the aggregates maybe with another table. And then in the end, you're sorting everything and you're kind of picking the top 10. It would be very classical query, right? Now, if you see on the left-hand side, Postgres would execute that fairly well, but Postgres would take minutes. And there's a couple of reasons for that. Number one is the parallelism applied is not so high, and then certain conditions, for example, distinct, etc., would actually turn a parallel query plan very quickly into a serial query plan. On the other side, you've got Swarm64, where we actually start with a much higher degree of parallelism. So you see many more small boxes there next to each other. And we're actually pushing through this execution pipeline very quickly, needing less RAM in the process, distributing things in between with our shuffle node. So you can actually no longer, you don't have to go serial from parallel at the point where, for example, the distinct condition comes in. And we essentially keep the query parallel for as long as possible. And that moves you from minutes of execution time to seconds of execution time.